So we're going to go over equations that are quadratic in form. Now, it's not necessarily that they're quadratic equations. In fact, you can probably see here that they're not quadratic equations. That's a fourth degree equation. Quadratic equations only have a squared term in them. But there's something about them that makes them quadratic in form. They can be made to look like a quadratic equation. So the question is, when is something quadratic in form? It's quadratic in form when the leading exponent, which I have here in yellow, is twice the middle exponent. 2 times 2 is 4, or 2 times -1 is -2. So that makes these things quadratic in form. Now, if we scroll down to this one down here, 5x plus 24 square roots of x equals 36. That one's not looking like it should be part of our list, 20. That is our list of things that are quadratic in form. But I actually maintain that it is. So how can we see that? Well, I guess the first thing that I would do is maybe I'll move the 36 to the other side. And get something like this. Or there's another way I can write the square root of x. And that is I can write it as x to some power. But what power is it that I can write here? Does anyone remember what the square root is? As a
1/2.
1/2.
Awesome. 1/2. Thank you both. And well done. So 5x to the first power plus 24x to the 1/2 power minus 36 equals 0. That's quadratic in form because this exponent is twice this one. So cool. Now, when that's the case, I suggested that we solve this with a little bit of a trick, a substitution. What was that substitution for a problem like this? Anyone remember?
Substitute u and u squared.
Excellent. Now u is going to equal this middle term, x to the 1/2. And automatically, because this is quadratic in form, automatically you're going to get u squared equals x to the first power or just x. And that's going to allow us to rewrite this in a more comfortable and familiar form. We can now write this as 5x squared. This can be 5u squared, right? Because instead of x to the first power, I can write u squared. Instead of x to the 1/2 power, I can write u. Now, this is just a temporary little fix to get around the fact that, boy, this is looking really ugly and ugh. So now I come down to here and you've got a tough choice. How are you going to solve this? There's basically 2 possibilities here for you. What are they? What are your choices to solve this quadratic equation?
Could factor or use the quadratic formula.
Excellent. You can factor and use the quadratic formula. Now, factoring this isn't necessarily a very easy thing for most of us, because factoring this is not like, you know, it would be if I had just a u squared here, and I can look for 2 numbers that multiply to -36 and add to 24. Because I've got a 5 there, it becomes much more challenging. You have to do the AC method. So that's when you multiply the outside numbers. It'd be 5 times -36 is -180, add to 24. You know, so what 2 numbers do that? 30 and -6. It's a lot of work. I mean, eventually it's going to factor down to 5u minus 6 times u plus 6 equals 0. And if you can do that, great. If you can't, then this is what you get to do. You get to use the quadratic formula, which isn't a whole lot of fun, but the quadratic formula does work. So starting out here, A, B, and C, plug it all in, simplify it some more. You end up with this. And by the way, if this number is a perfect square, you know, like the square root of 1296 is 36, that's telling you, oh, you could have factored it. You know what? Big deal. All right. You're still going to get it right if you use the quadratic formula. You get 6/5 or -6. Same thing here. If you factor it, you get two possibilities. Either u plus 6 equals 0 or 5u minus 6 equals 0. And that means u equals -6 or u equals 6/5. Obviously, if you can factor it, that's better. But either way, you should be able to solve it. Unfortunately, that's not it for our solution, because we didn't start out to solve a problem in U. We had a problem in X. So let me go finish solving this then. We had U is equal to 6/5 or U is equal to -6. But U is just a temporary replacement for X to the 1/2. What did I say about solving something like this? There was a trick. You had to raise both sides to a particular kind of power.
Reciprocal.
Reciprocal power. And the reciprocal of 1/2 is 2. Yes, 2. Thank you. So if I square both sides, 2 times 1/2 gives me x to the first power. And squaring this gives me 36/25. So that's one part of it. Over here, when I square both things, again, 2 times 1/2, you're multiplying a number by its reciprocal, so you get just a 1, x to the first power. And -6 squared is 36. And boy, I know this problem feels like it's gone on for a long time, and it has, but you're not quite done. That's because right here, even though it's not really written, you've got this equation, square root of x equals -6. And you might remember from just our last test that when you square both sides of an equation like this to get an answer to help solve, what else do you have to do? You have to check your answer. If I plug in 36 here, does that work? Does the square root of 36 equal to -6?
No.
No. So this one is an extraneous solution. It doesn't work for the original problem. Won't even work in here. This one actually does check. If you take the square root of 36/25, a square root of 36 is 6, square root of 25 is 5. That one works. So I know it's a long problem. It's a lot to do. Sorry. I promise not to put any more than 30 of them on your next exam. All right, maybe a few less.
I have a question.
Yeah, Grace.
You have to check both answers every time, or only if there's a square root, if x is under the square root?
To be very direct, it's if you're squaring both sides to get a solution. Now, it's not going to be a problem if you're cubing both sides. It's if you have to raise both sides to an even power, that's when you have to check your solutions. So I will do one more problem from this section, kind of like this. And you'll see that, okay, you don't have to check it in this situation, but are we good with this one right here? Can I move on? Or if there's something more that's bothering you, let me know. All right, let me do one more, which should be a lot easier, and kind of answer Grace's question directly. So r to the 2/3 plus 4r to the 1/3 minus 5 equals 0. If you take a look at the first exponent, which is 2/3, and you multiply that by 1/2, now usually I cancel, but I'll show it a different way. Half of the first exponent is the middle exponent. So half of that exponent does give me this exponent. And all that's saying is that it's quadratic in form. So we're good there. Now, that suggests a substitution. Can anyone tell me what that substitution is going to be? What should I let u equal? R to the 1/3. And I appreciate very much that you didn't just say 1/3, because it's the whole variable term there. This would be r to the 2/3, and that becomes u squared plus 4u minus 5 equals 0. Got to apply some Photoshop here. And this is a much nicer problem. Can anyone tell me why? It factors. Yeah, it factors. So Michael, go ahead. How does this one factor?
X plus 5 and x minus 1.
Excellent. So u plus 5, u minus 1.
Oh, I'm sorry, u.
And that it gives me two solutions. Now it's important to remember that we didn't start out with a problem in u, right? We started out with a problem in r. So I'm going to put that r to the 1/3 here equals -5, and r to the 1/3 here equals 1. Grace, this is where I'm coming back around to your question. I got to raise both sides to the reciprocal power to finish solving. What power am I going to use in this case? What power do I raise both sides to finish this one up?
3.
3. It's the reciprocal of 1/3. If this was an even number, then I'd have to go back and check. But when it's an odd number, and I'm not going to explain all the details as to why, but when it's an odd number, it doesn't present that problem. -5 cubed is -125, and 1 cubed is 1. So there's your two solutions. Nice. How are we looking on that one?
Good.
A little bit friendlier of a problem, I think.
Yeah.
I'm going to stop the recording here and put you back in your rooms so you can keep working.